first thing to understand is, what does Geotab do that makes us unique in the way that we gather data? So this is really an engineering problem. How do we get the rich set of data that your vehicle generates? And vehicles are generating literally gigabytes of data every single day around oil temperature, pressure, every measurement of every sensor in the vehicle, everything that's happening in the vehicle is being made available in real time. Now, how do we get that data back to the servers where we can analyze the data? Now, one of the options you have is to create all these algorithms and try and run them in the device. So the device is going to do all the work and decide, okay, this is a harsh braking incident, do that, do that, do that. And it really is a bad approach, because what if you want to go back in time and try a different algorithm? What if your algorithm's wrong? Or what if you want to apply new algorithms that you didn't think of in the past? It's a far better approach to get the data up to the servers and then try and process it on the server side. So that's the engineering problem. How do we get this rich set of data back there without overwhelming the systems, without having so much data that you literally cannot get all the information back? So we came up with an approach that we call our curve logic approach. So we have a number of patents around this. We think it's a really smart approach for how we do this. And the way for me to illustrate that is on the board, show you how it works. So imagine that I'm driving a vehicle and I'm driving down the road here, and then I hit a T-junction and I turn left at the T-junction, and then I turn right at the next T-junction, and I drive like this. Now, these dots represent the position of the vehicle 1 second apart. So the GPSs tell me where I am 1 second and the next second and the next second. Now, if I send all that data to the server would be completely overwhelmed. Now, what many of our competitive products do is they will sample the data maybe once every 30 seconds, 15 seconds, once every minute, or once every 100 yards. They'll have different algorithms for doing this. So they might sample here and coincidentally sample here, and another sample might be there. Now, this is where the problem comes in, because if you look at what it looks like the vehicle did, the vehicle drove through buildings, right? The distance that's being calculated is completely wrong. This is the distance that I drove, but look at the way the distance comes out, much shorter than what the actual distance was. So it doesn't work well at all. So what Geotab does is we use the curve logic algorithm. So this runs in the device, in the little device itself. And what we do is we say, okay, imagine that the only points that we send to the server were these, the beginning point and the end point. So that would mean that the server would think that we actually drove right through the buildings over here. And then what the algorithm does is it says, okay, what is the point of maximum error? So if we look along this line here, we say, okay, well, the point of where there's the most amount of error is this point here. It's very far away from where we think it is. So we thought it was going to be here, but it's actually up here. So let's send the point of maximum error. So what means we send this point to. Interesting. So now what we do is we run the algorithm again recursively. So we say, okay, well, what if we just sent this point and this point? What is the point of maximum error? And guess what? The point of maximum error is so small, we don't have to worry about it. So we don't need to send these other points through here because they're carrying no information. We run the algorithm here again, and we think we drove across through the building again. So what we have to do is send this point here, the point of maximum error. And then we run it again on this set, and we realize there's no more information. We run it on this set, and we realize there's no more information. So interestingly enough, what we've done is we've taken having to send through 100 points on position, and we've broken it down into 1, 2, 3, 4 points that we need to send. An incredible saving. We've thrown away the points that essentially were not carrying any information. And that's the key thing about what Geotab does. So this is how the GPS works. But then we thought, well, what if we could apply it to the rest of the things we measure? So we did that, and we said, let's think about speed for a second. So imagine now I have a graph up, and this is my speed, and this is time. Now I'm driving along the highway, and I'm going at 70 miles an hour, and then I overtake something like that. Now again, what might happen with competitive systems is we might log here, we might log here, and we might completely miss the infraction. So what does the Geotab curve logic do? Again, we apply the curve logic to this curve, and we say, well, we've got this point here from before, we have that point, we have that point, we have that point. So in essence, we have a much more accurate representation of the speed curve. Very, very powerful. So now we get the minimums, we get the maximums, we get how long you were speeding for. We know very accurately how long were you above the 70 mile an hour limit for. Very, very powerful. So then we said, let's even take it further. What if we applied that same logic to everything that we do in the vehicle? So one of the ones that's really interesting is accelerometer. Now, many of the insurance companies out there, they like to measure how well you're driving. We all know that you can put a telematics device for some insurance companies, you can get a discount on your insurance. And every insurance company has a secret formula that the actuaries came up with about how they measure how well you're driving. And they measure how hard you're braking, how often you brake hard, and they have a whole bunch of measures. Now, you don't want to build that kind of algorithm in the device because a different insurance company is going to use a different algorithm. So we use the curve logic to give you the accelerometer curves, and then you as an insurance company or a provider can do your own calculation. So this is how we do it. So again, we say, imagine this is X, Y, and Z. So this is the acceleration in each of those planes. So we'll put X, Y, and Z. So in the X plane, this might be happening. In the Y plane, something else might be happening. And in the Z plane, because you've got gravity pulling you down, you might get a little wobble here. Now again, what we do is send through all of these magical points, and each insurance company can now do the calculation the way that they want. And that becomes very powerful. I'll give you some very interesting use cases for how, for example, you could use the acceleration in the Z plane. In Japan, one of the municipalities over there deploy it in all of their government vehicles, a Geotab unit. And then they have an SDK application that just monitors for disturbance in the Z plane. Now you might wonder, why would you be interested in knowing what's happening with the vehicle up and down? Well, when you hit a pothole, you're going to get a big disturbance in the Z plane. And that's very interesting because guess what? The application then calls their dispatching system and says, go and dispatch a crew to fix the pothole, and there's the location of the pothole. Very powerful stuff. All automatic. So that's how we can leverage that. Now, with the same thing we do for acceleration, we do for all of the measures in the vehicle. So you can take oil pressure, oil temperature, battery voltage, even seatbelt utilization. Everything that we can measure in the system, the curve algorithm gets applied to. And I want to talk about a really important one, and that is battery voltage. So let me draw that up for a second. So this is the voltage of the battery, and this is time. And this is kind of key, because what happens is we can tell an awful lot about what's happening in the electrical system in your vehicle based on this signature. So our large fleets tell us that 80% of the failures that happen in large fleets are caused because of the electrical system. That means if I'm a vehicle and I'm out on the road, my starter motor doesn't work, my battery runs flat because the battery's dying, or my alternator's not working. 80% of the failures are caused because of one of those three things. So how can our curve logic and our intelligence help with that? Very clever. So what we do, we know battery voltages in vehicles are 12 volts. So we know that if that thing is degrading over time, you're discharging the battery. So we know that you've left the lights on. When you come to start the vehicle, interesting thing happens. You're essentially putting a short across the vehicle, and the starter motor is then engaging, and then you get a ripple effect as the starter motor engages, and then it goes up to 13.4 volts, which is the voltage where your alternator charges the battery. And because we send the exact detail of this through the curve logic to the server, we can run machine learning algorithms. Algorithms that humans in the past could only do, that machines can now do, to recognize shapes in these curves that tell us that the battery is going to fail. So the machine learning algorithm will recognize that you're discharging the battery, you left the lights on. It can recognize that the ripples in this curve are too big and that the starter motor is about to fail. It can recognize how deep this drop is, so it can say that you're overloading the battery. It can also take into account the temperature to know that, hold on, it's very cold, I expect it to go deeper. It's not cold, I don't expect it to go deep. And it can recognize that this thing should go up to 13.4 volts when the alternator kicks in. Very powerful stuff. This is game-changing stuff that can be done because of the way we record the data. Because we make that data available on the server using our curve algorithm, that data can now be algorithms can be applied to that data to do some amazing things. And believe it or not, if we could cut the number of downtimes that large fleets are seeing by the numbers, 80%, the bottom line difference to businesses is phenomenal. The amount of money that they can save, the profitability increases, and it can give them competitive advantage over any of the other competitors that are not thinking about this stuff and not following the same logical approach. And that's why companies are adopting Geotab in mass, is because they're seeing radical differences to their own businesses. In a way, think about what Uber did to the taxi industry, and think of Geotab as your product where you can essentially become the Uber of your own industry. Take the same technology that Uber adopted and change the face of the way that your industry works using techniques like this, make yourself more productive, use less vehicles, be more efficient. And that's the approach.